Today we are talking about graphs with decimals. It's lesson 2.9 and it is the last lesson in unit 2 before we review and take the test. So when you pause the video, I want you to also go find page 67 of your math workbook. So you'll need a lime green, a purple, you'll need a pencil, you'll have to set up the title, the lesson number and the date, plus go get page 67. Go ahead and push pause on the video to get all of that accomplished. What we're going to be doing is actually setting our journal aside and working on page 67, and then we're going to be cutting and gluing into our journal because I don't want to have to draw all of the graphs and waste our time doing that. Instead, I'd rather have us look at graphs, interpret them, understand what's going on, and how to represent different amounts. So we're working on page 67. Please put your name and number on the front and on the back. We're going to use this graph to answer questions 1, 2, 3, 4, and 5, I believe. It says graphs with decimal numbers. This bar graph shows the length of some common beetles. Okay, an insect. What is the length of a bark beetle? So we come here. This is the title of the graph. Length of common beetles. Here is the measurements. It says it's in centimeters, and here are the different kinds of beetles. These are called headings kind of for graphs right here, and that's the title of the graph. So you have to have the measurements, you have to have the subjects, and the title. Notice how over here on the graph, each increment is moving up by the same amount, the same distance, just like a vertical number line. In fact, if I were to cover all of that up, you could imagine this as just a vertical number line, starting at 0, going all the way to 1.4. So from 0 to here was 0.2. So what's halfway in between 0 and 0.2? 0.1. So each of these little tick marks on the graph is actually going up by 1/10. 0.1, 0.2, 0.3, 0.4. I know that might seem a little boring to go over that, but that is going to be really critical in today's lesson, that you understand that the increments that a graph goes up has to be consistent. It has to be the same amount from here to there, 0 to 0.2, as it does from 0.2 to 0.4. That needs to be the same measurements. Okay, I'm going to go ahead and erase that. Let's answer number 1. What is the length of a bark beetle? Find a bark beetle. Go up. It's exactly in between 0.2 and 0.4. And what decimal number is between 2/10 and 4/10? 3/10. So the answer is 0.3. But then we need to put measurements, and it's in centimeters. 0.3 centimeters. Number 2, how much longer, will you pick up your green? What does that mean? What do I know that means? Subtraction. Number 2, how much longer is a firefly than a bark beetle? So you have to go to firefly. You're going to write this number down, and we know bark beetle, 0.3, and you're going to subtract them. Okay, I'm going to do that right here. The firefly goes clear up here to 1.3. So I put 1.3 on the top. I'm going to be doing subtraction because of how much longer. And the bark beetle was 0.3. So you line up the decimals and the place values. You button up the decimals. 3 minus 3 is 0. 1 minus 0 is 1. So what is the difference between a firefly, or how much longer is a firefly than a bark beetle? It is 1 centimeter longer. I'm going to say 0.0 because that's what the measurement is right there. 1.0, or you could just say 1. Number 3, estimate. So look at this. We are actually practicing a lot of skills here. We practice subtracting decimals. We're practicing reading graphs. And now we're going to practice, look at number 3. Estimate. Pick up your purple. Estimate means we're going to be using rounding. Estimate the length of a tumblebug in hundredths of a centimeter. So let's go find Tumblebug. Tumblebug. Oh yeah, they are going to want you to estimate because look, here, let's just go ahead and label this. This would be 0.9, right? 0.8, 0.9, 1.0. So they're saying, look, it's not quite 1, but it was more than 0.9. So we're looking at this distance right here. I'm going to use my green for this to show you. We're looking at it from this distance. And they've marked it right about there. So if you think about that, remember these can all be hundredths. How do you get all of these to be hundredths? You simply add zeros at the end. So right now it was between 0.9 and 1, so it looks kind of like this. Here was 0.9, and here is 1.0, right? And it's right here. So they want you to estimate in hundredths, so use your rounding to think about that, to go, well, this is 90, remember you can always add zeros, and this would be like 100. So what's right in between 90 and 1.0? 0.95. So that would be a pretty good estimate. If you think it's a little more than half, you could put a little more than half. I think it's pretty much halfway. So I would say 0.95 centimeters. That's a pretty good guess. Maybe 0.96, but that's pretty close. So I would accept either one of those answers. Number 4, the actual length of one beetle shown is 0.150. Which beetle is that? 0.1 means that it can't be clear up here. It's going to have to be a pretty small one because here's 0.1. Will you label that on your graph? 1. So where's 0.15? It doesn't mean you go clear up here to 1.5. That's not what it means. It means that you look at 0.15. So think about it like this. If I have, let's draw it again, 0.1, what's the next tenth? 0.2. You can always sneak in the zeros, 0.10, and that says 0.20. So 0.15, oh, we're looking for thousandths. I'm sorry, let's add another 0. So we can get them to thousandths. There we go. 0.100, 0.200, 0.150 would be right here in the middle. So this is 0.150. So what you're looking for is a number that was in between, I'm going to use my green, a number that was in between 0.1 and 0.2. Do you see a beetle graph that's in between 0.1 and 0.2? I do. It's the seed beetle. Did they capitalize beetle? They did. Sorry. There you go. Seed beetle. Okay. Number 5. A June bug. So that's not one of these. It's a different one. A June bug is about 2.5 centimeters in length. About how many times as tall as the tumblebug bar? Where's tumblebug? Right here. What did we decide tumblebug was? We decided it was 0.95, right? So tumblebug was 0.95. And Junebug, they're saying, is 2.5. So they're asking, about how many times as tall would that graph be than this one? It says, hint, round the lengths to whole numbers to help you estimate the height of the Junebug's bar. Okay, so we're going to round to whole numbers. That's what they've told us to do. So we're going to take 2.5 rounded to the nearest whole and 0.95 rounded to the nearest whole. Okay, remember to round. This is a practice. We underline the place value they're asking for. Let's begin on the top. This is the ones place, the whole numbers. The 2 looks over at the 5 to the right. The 5 is the boss. The number on the right is the boss. It tells that number to do something. 5 or more, raise the score. So 2 changes to 3. Everything in front stays the same. There's nothing in front. Everything behind disappears. So it's just 3. Next, the 0 looks to the 9. The 9's the boss. The 9 tells the 0, hey, 5 or more, raise the score. What does 0 change to? 1. And everything behind it goes away. So a June bug is about 3 centimeters. And the tumblebug is about 1 centimeter. So how many times as tall would this graph have to be? So what they're asking here is how do you get, let's go, times as tall, underline that in purple, and come over here. How did I get from 1 to 3? I times by 1 to 3. I times by what? Hopefully you said it. 3. So it means that that would be 3 times, almost 3 times. I mean, not quite because we rounded them both up, but I would maybe come here and say it would be about 3 times as tall. And when I use the word about, it means that I definitely use rounding or estimating and it's not perfect. But I did do a close guess and that's why it works out pretty well. Okay, let's take a look at Puzzled Penguin. What's the error? Oh, he's got some confusing looks again. Dear math students, for the science fair, I recorded the heights of several plants. A month after I put different fertilizers on them, I made a bar graph of the data. Did I make my graph correctly? If not, how can I fix it? Let's take a look. He's got a title. He has these labels on the sides and on the bottom. So he's got measurements and the subject. So plants and the height, so how tall they're growing. And he's got a good title. So far he's done the title, the labels correct. He's got solid colored and bar graphs with different colors representing things. That's pretty nice. So far he's doing pretty good. But we have an issue. See if you can look over here. This is called the y-axis. It's going up and down. See if you can see a problem. If you notice that there is not an equal distance between each point, then you did it really correctly. Take a look. He starts right here at 0. Then he jumps up a whole number. He goes literally all the way to 1 whole. So the next thing, if he was going by 1 wholes, what should the next number have been? 2 wholes. Then 3, then 4, then 5, then 6, then 7 wholes. So whatever he chooses on this first increment, I'm going to use green, he has to continually go up, and he didn't. However, once he gets to 1.3, he does start to go up by something. What does he go up by? Tenths. 1.3, 1.4, 1.5. Those are going up by 1/10. So he does it correctly from this point forward, but he did not do it correctly beginning here. So an answer to Puzzle Penguin, we're not going to spend time writing it out, but an answer to him would be, you need to make sure that your measurements are going up in the same increments or going up by the same distance for each mark. That would be a good response to him. I'm not worried about us writing that though. Will you please turn the page over? In the next video, we're going to go over how to do page 68, and then we're going to be cutting and gluing some of these things into our journal. So check out the next